You know what our night sky looks like, right? The moon, a few planets, that beautiful splash of the Milky Way. It's gorgeous. But let's be honest, compared to a giant like Saturn, it's also kind of empty. So why is that? Why doesn't our planet have its own spectacular set of rings? Well, the answer is this incredible story of gravitational violence, a ghost in our planet's past, and the unbelievable luck that allowed us to even be here at all.
Okay, just stop for a second and really picture this. Forget the sky you know. What if every single night this was your view? This magnificent glowing structure just dominating the heavens. It would change absolutely everything about how we see the world and our place in it. And the craziest part, the view would be completely different depending on where on Earth you are standing.
So let's say you're at the equator. You'd be sitting right in the plane of the rings, looking at them edge on. And what you'd see is this perfect, impossibly thin line of light, just slicing the sky in two. What's so wild is that this line wouldn't move, ever. The stars would spin overhead, the sun and moon would rise and set, but that celestial razor, it would stay absolutely fixed, a permanent glowing equator in the sky.
Now, let's move to where most of us actually live, the mid-latitudes. Think somewhere like Tokyo or Washington, D.C. From here, the view totally transforms. It's not a line anymore, it's this massive, glorious arch stretching from one horizon all the way to the other. And we're not talking about some faint, wispy thing. This arch would be so bright it would create a permanent twilight, bright enough to read a book by, even in the middle of the night with no moon.
And finally, if you were brave enough to be standing at the North or South Pole, the rings would be almost totally hidden by the curve of the Earth. All you'd see is this low, constant glow on the horizon, kind of like a huge city just out of sight. It would literally create a planet of celestial haves and have-nots, where your latitude would decide if you lived under a brilliant arch or just a faint glimmer.
So why don't we see this? I mean, as beautiful as that all sounds, our sky is clear for some very specific reasons. This isn't just some cosmic accident. The universe has rules, and to figure out why we're ringless, we have to start with the most important one.
And that rule is called the Roche Limit. The easiest way to think of it is as a gravitational kill zone around a planet. If a moon or an asteroid gets too close and crosses this invisible line, the planet's gravity starts pulling way harder on the near side of that object than on the far side. That difference in pull, that's the tidal force, literally rips the object to shreds, smearing its guts into a ring. It's the ultimate no-fly zone for anything big in orbit.
And right here is where it all starts to click. Earth's Roche limit is about 18,000 kilometers out from the surface, but our moon, it's orbiting at a super safe 384,000 kilometers. That's more than 20 times farther away. It's not even close to being in danger. Now look at Saturn. Its main rings exist almost entirely inside its Roche limit. Those rings are the beautiful ghost of something that got too close and paid the ultimate price.
But it's not just about the Roche Limit. The other huge reason our sky is so clear is our moon itself. See, compared to the size of Earth, our moon is gigantic. It's weirdly large for a planet our size. And its powerful gravity acts like a cosmic vacuum cleaner. It just bullies any stray debris, either flinging it out into space or sucking it down to Earth. Saturn, on the other hand, has these tiny little shepherd moons that weave through the rings, using their gravity to neatly herd the particles and keep the ring's edges perfectly sharp. Our moon does the exact opposite. It makes sure nothing sticks around for long. So, a strong gravitational rule and a giant lunar bodyguard keep our skies clear today. Case closed, right? Well, not so fast, because what if I told you that our ringless sky is actually a pretty recent development, geologically speaking? What if I told you Earth has had rings, not once, but twice before?
Yep, you heard that right. The geological record points to two distinct times when our planet was decked out with a ring system. The first was way back in the chaotic beginning, 4.5 billion years ago, when a Mars-sized planet named Theia smashed into the young Earth. The second happened much more recently, during the Ordovician period, when life was already flourishing in the oceans.
That first ring, the one born from the Theia impact, was incredibly dense, but it didn't last long at all. The rubble outside the Roche limit immediately started clumping together into little moonlets. Then the inner part of the ring spread out, pushing those clumps farther and farther away until, and this is fast, in just a few hundred years, all that material had been swept up to form one single massive body, our moon. So in a very real way, we traded a spectacular ring for the moon we have today. Okay, so Earth's second set of rings formed about 466 million years ago. This time, a huge 12-kilometer-wide asteroid just wandered too close,
crossed that Roche limit and was torn to pieces. But this ring would have looked totally different from Saturn's. Saturn's rings are so bright and white because they're like 95% pure water ice. Earth is too close to the sun, inside what's called the frost line, so our ring would have been made of dark, stony silicate rock. Much dimmer, kind of sooty, with about the same reflectivity as a blackboard.
Now, how can we be so sure this happened? Because of this number right here. This is the smoking gun. Scientists looked at 21 major impact craters from that exact time period, and every single one of them is clustered near what used to be Earth's equator back then. The odds of that happening just by chance? 1 in 25 million. That's not a coincidence, people. That is the clear signature of a decaying ring system, raining down rocks almost exclusively on the planet's midsection.
So Earth has had rings, but they were temporary. And you know what? That turns out to be an incredibly lucky thing for us. Because, as beautiful as a permanent ring system would be, it would also be a curse. A beautiful, terrible curse that would have fundamentally changed our planet for the worse.
First up, the climate. A ring would cast this massive, permanent shadow that would shift with the seasons. And climate models show this would plunge the planet into a deep freeze, cooling global temperatures by up to 8 degrees Celsius. This sudden cooling is actually the leading theory for what caused the Hernantian icehouse, one of the most severe glacial periods in Earth's entire history, which, surprise, surprise, happened right after that Ordovician ring formed.
And then there's the impact on life itself. The constant ring light at night would create this perpetual twilight. This would be absolutely devastating for so many species. Dung beetles navigate using the faint light of the Milky Way. They'd be hopelessly lost. Sea turtle hatchlings follow the moonlight to the ocean. They'd be scuttling inland instead. The synchronized spawning of coral reefs, which is timed perfectly to the lunar cycle, would be thrown into total chaos. For just about all life, it would mean chronic stress and sleep deprivation.
And for us, for a modern, technological civilization like ours, a ring system would be a planetary prison. It would be a near impenetrable barrier, effectively trapping us on our own world for good.
You've probably heard of something called the Kessler syndrome. It's the nightmare scenario for space travel, right? Where one collision creates debris, which causes more collisions, creating a deadly, impassable belt of junk around the Earth. Well, a natural ring system is a permanent, unavoidable Kessler syndrome. We wouldn't have to create it, we'd be born into it.
The danger here is just it's almost impossible to wrap your head around. The little particles in a ring are zipping around at hypervelocity speeds, many kilometers per second. At those speeds, even a tiny fragment weighing a single gram, about the mass of a paperclip, hits with the kinetic energy of a 2-ton rhinoceros charging at you at 30 miles per hour. A ring system has trillions upon trillions of these little bullets, making any launch through it basically a suicide mission.
And that means the world we live in right now, today, simply could not exist. Think about it. Without satellites, no GPS. That could cause a collapse in agricultural efficiency, leading to food shortages. Global telecommunications and the internet, they'd grind to a halt. We'd be blind to incoming hurricanes, unable to monitor wildfires from above. Our entire global infrastructure is built on having access to space, and a ring system would slam that door shut.
So, when we look up at our clear, dark night sky, we shouldn't see it as a place that's missing some grand cosmic feature. We should see it for what it truly is, a gift.
Our clear sky isn't an absence, it's a presence. It's the presence of the gravitational stability that our giant moon gives us. It's the presence of a stable climate, not one trapped in a permanent ice age. And maybe most importantly, it's the presence of an open gateway, a clear and inviting path to the rest of the cosmos that has allowed us to explore, to connect, and to understand our place in the universe. We look up and we see empty space. But what if that emptiness is the single most valuable and maybe even the rarest feature of our entire world? What if having a clear path to the stars is one of the essential ingredients for a civilization like ours to even get a chance to exist? It's something to think about the next time you look up.